Well, you specifically will use this math in Algebra 2, which is going to be in your life at some point because you decided to do an accelerated track. Also, you'll use this on the ACT, which will hopefully give you a high score and get you into the college that you want if you're wanting to go to college. You know, I'm not sure. And anyway, so the first thing on here, the essential question says, how does recognizing patterns in the signs help you factor polynomials? So this one, A is equal to 1. Oh no, that marker's too big. I need to fix it. Hold on. Okay. So your A is 1. That just means there's no number in front of x squared. But what you should notice in this case is that this is your A, this is your B, this is your C. B is positive, C is negative. So we're going to do the puzzle. We want something that multiplies to give you negative 15 and something that adds to give you 2. I know you guys are thinking 5 and negative 3. I know that's where your head was at. So there we go. And I know it's been a minute, but when your A is 1, you don't even have to do the box method or anything. You use your puzzle pieces. So you start with an X. If this is a positive 5, you say plus 5. Then you have another X. And since this is a negative 3, it would be minus 3. Okay, so when your B is positive and your C is negative, you're going to have one positive answer, one negative answer. Always. The next one, this is A is positive, but B and C are both negative. So we're going to solve this one, but make sure you know that the B has a 1 in front of it. I got to sneeze. Okay. Anyway, we're going to take A times C. 3 times negative 6. Negative 18. And, oh man, that 8's bad. B is negative 1. So something that multiplies to give me negative 18 and adds to give me negative 1. You could sit here all day long. And I mean, there's not that many things that multiply to give you 18. There's 9 and 2. That's not going to get me negative 1. And there's 6 and 3. And that's not going to get me negative 1. So this is what I'm saying. When you learn the quadratic formula, this is why. This one, we're going to say it's not factorable. There is no answer to that puzzle. That happens sometimes, and that's why the quadratic formula exists, and we will talk about that later. So it is possible to get something that is not factorable. Okay, so those are some special cases. Just quickly, though, this is where we're headed. It says factor the polynomial x squared plus 14x plus 49. So we're going to factor this like we normally would. Keep in mind your first number is 1. So if you took 1 times 49, the top number would be 49. The bottom number is 14. Something that multiplies to give me 49 but adds to give me 14. 7 times 7. This is, since the first number is 1, you just have to pick an x. It's a positive 7, so you put plus 7. Then you do your other puzzle piece, which is an x plus 7 as well. So the question says, what do you notice about the factors? They're the same thing. What's another way you could rewrite that? You write one of them, and then you square it. It means, hey, I have 2 of the exact same binomial. So if you ever get the exact same factor, most of the time they're going to write it like this. They're going to write the binomial, and then they're just going to square it. That just tells you I have 2 of the same thing. Okay, the next ones, these are examples of perfect squares, okay? If what you know about the number 4 is that 4 is a perfect square. What you know about the number 9 is that 9 is a perfect square. You can absolutely do this the way you learned with the puzzle and the box and all of that, but there's an easier way I want to show you really quick. What is 4? What is the same thing as multiplying by 4? I didn't say that right, but it's 2 times 2. 4 is the same thing as 2 times 2, and 9 is the same thing as 3 times 3. What is x squared the same as? So this would be like saying you have 2x times 2x. All right, if your middle number is positive, you know that both of your signs are going to be positive. So you're going to take one of your 2x's and one of your 3's, and that's a positive 3. That's why I put a plus sign. Then you're going to take the other one, 2x, and you're going to take the other 3. How else could you write that? Yeah, so you could absolutely do this the way we learned, but if you notice that the first number and the last number are perfect squares, you can just kind of like factor those out itself without having to do all the puzzle stuff. This one is a little bit different because the middle number is negative. In the first example we had, the middle number was positive. In this example, the middle number is negative. X squared is the same thing as x times x. 16 is the same thing as 4 times 4. The difference here is that middle number means you're going to have a negative sign instead of a positive sign. So I would put an x and a minus 4 in the first one, and I do the same thing for the second one. If you think about it, and I'm just going to prove to you that this works, x times x is x squared. I'm just FOILing or multiplying basically. X times negative 4 is negative 4x. Negative 4 times x is also negative 4x. And negative 4 times negative 4 is positive 16. Then you add or you combine your like terms, and those would equal negative 8. So anyway, that would mostly be written like this, x minus 4 squared. The sign is important of that middle number. If your middle number is positive and your last number is positive, it'll be a plus sign. If your middle number is negative, but your last number is positive, it will be a negative sign. And here's the last couple types of problems. This is on the back of your notes. This one, there's only 2 numbers. There is no B. Okay, you have like the A number and you have the C number. You don't have the B number. So you do the exact same thing. I'm just going to write this again so you can see it better. You're breaking x squared into x times x. You're breaking 9 into 3 times 3. When you have a minus sign like that, and you only have 2 numbers, one of them is going to be a positive and one of them is going to be a negative. You just have to think, how could I get to negative 9? So I'm going to have x plus 3, and I'm going to have x minus 3. When you have this minus sign right here, you do one of each. And we're going to practice a couple more of those. This is the same situation. X squared is x times x. 64 is the same thing as 8 times 8. And there is that minus sign between the two terms. So it would be x plus 8 and x minus 8. This is called the difference of 2 squares. What does difference mean? Like what operation? So you have to be subtracting to be able to do this little quick tip right here. It cannot be an addition sign. It's called the difference of 2 squares. So if there's not a minus sign, you can't do it. This one's a little different because you have a 4 first. 4 is the same thing as 2 times 2. And x is the same thing as x times x. So you're going to have 2x's. 9 is the same thing as 3 times 3. This is the difference of 2 squares. We have one that we can square here, and we have another perfect square here, which means you're going to have a plus sign in your first and a minus sign in your second. 2x plus 3 and 2x minus 3. Okay, the last one is right here. Right here. Can you factor x squared plus 16? Explain why or why not. Is that the difference of 2 squares? the problem right here is the plus sign. So we're going to say no because it's not the difference of two squares. That's like the sum of two squares. It's not the difference of two squares. Okay. It says explain why or why not, but we kind of did. It has to be the difference of two squares. So we are gonna get our books out and a piece of paper out. We have about 15 minutes, but we're just gonna work on some of these together today. So get your book out and turn to page 305, please. Yes. Okay, so we're on page 305 when you get your book. Oh, thank you. Hunter, there will be a video that you can do the notes. We're just in our books on page 305. Okay, we're gonna start with number 30. It gives you this. And keep in mind, it's telling us to do the evens, not the odds. So we have the number 144 x squared minus 24x plus 1. All right. So we need to break down, like you can do the puzzle for this if you want to, but what I know is that the first number and the last number are both perfect squares. 144x squared breaks into 12x times 12x. 12 times 12 is 144, and x times x is x squared. 1 is the same thing as 1 times 1. What I told you before is you got to pay close attention to that middle number. If the middle number is negative, that's going to make our signs negative. We're going to see what happens. 12x. All right, so here's what we would have if we did that, and we're going to check our work to make sure that this is true. 12x times 12x is 144x squared. Negative 1 times 12 is negative 12x. 12 times negative 1 is also negative 12x. And what's negative 1 times negative 1? Positive 1. If you add negative 12x plus negative 12x, you're at negative 24x. So anyway, this is your answer right here. I kind of made a mess around it, but 12x minus 1, 12x minus 1. You could also write 12x minus 1 squared. There we go. There's number 30. We're doing even, so we're going to skip to number 32. 32 is the difference of two squares is x squared minus 25. Since this is a minus sign and it's the difference of two squares, you're going to have 1 plus and 1 minus. X squared breaks into x times x. 25 breaks into 5 times 5. So in your answer, you're going to say 1 is plus and 1 is negative. And that's going to be your answer. I could show you how that works if you wanted to multiply it out, but I'm going to skip that step for right now and move on to number 34. X squared. I honestly think we did this one in our notes. Someone go look. What did we get for the answer? We could do it very quickly. We have x and 7 and 7, so x plus, it was a positive. So you're going to have x plus 7 and x minus 7, because this, oh, no, they're both going to be minus, sorry. It's not the difference of two squares, it's three numbers, so that's how you know. Oops. So we know x squared breaks down into x times x. 49 breaks into 7 times 7. Since the middle number is negative, they're both going to be minus. I'm just going to skip a step because I know they're going to be the same. I'm going to put x minus 7 squared. What number are we going to? 38. Okay, we're going to stop at 38. So here's 36. 16x squared plus 40x plus 25. This is still an example of having a special case because the first number is a perfect square and so is the last number. This makes your life a little bit easier because for me, I don't really want to take 16 times 25. I don't want to do that. That's a lot of work to find a puzzle that works, like the puzzle that works for that. So what I can do is I can break 16x squared. 16 is the same thing as 4 times 4, and x squared is the same thing as x times x. 25 is the same thing as 5 times 5. You do have to pay close attention to your middle number. If the middle number is positive, you're going to use plus signs. So I know I'm going to have the exact same thing. It's going to be 4x plus 5. You can write it twice, or you can just write squared at the end. And then 38 is the difference of two squares. I know this because there's only two terms in the problem, but this one is weird because it has an x squared and a y squared. So you've got 16x squared, which is a perfect square. You can factor it like that. And 81y squared is still a perfect square. I forgot my one. There we go. So think about what you can make this turn into. 4x times 4x. What can I make the other one turn into? 9y times 9y. 81 is the same thing as 9 times 9, and y squared is the same thing as y times y. So now, since I know this is the difference of two squares, I'm going to use both, but I'm going to have a plus sign in one and a minus sign in the other. So there's my plus sign. The next one I'm going to use the other two, but it's going to be a minus sign. The hardest part of this is figuring out what you're working with. You just have to make sure you know, is it the difference of two squares, or if it's not, is the middle number positive or negative? That's important. We have a couple more problems we're going to do. We're going to do number 49. It's on the next page. In front of a school are several gardens in rectangular raised beds. For each one of the areas of the rectangular gardens, give us factoring to find its possible dimensions. Can the garden be squared? If so, explain why. So they give us an A, a B, and a C. We have to factor A. This one is a perfect square, and the middle number is positive. I'm just going to actually write it down. You don't have to do this, but I'm writing it down so you can see it. We have to figure out what two things multiply to give you 256. What is it? 16 times 16. So this is going to be, since my middle number is positive, this is going to be x plus 16 squared. You could also just say x plus 16, x plus 16. That's A. B, this is the difference of two squares. You have x squared minus 4y squared. X squared is the same thing as x times x. 4 is the same thing as 2 times 2. And y squared is the same thing as y times y. So since this is the difference of two squares, you're going to say x plus 2y and x minus 2y. Now the first one, could that be a square? What is the what's the word I'm looking for? What's unique about a square? All the sides are exactly the same. Are these two sides the same? Yeah, this one could be a square, but could the second one be a square? Are the two sides the same? No, this one can't be a square. C, x squared minus 20x plus 100. X squared is the same thing as x times x, and 100 is the same thing as 10 times 10. The middle number is negative, so that makes your last or your signs negative. So it's going to be x minus 10, x minus 10, or you could just say x minus 10 squared. So could this one be a square? What time is it? A couple more minutes. We have plenty of time. 52. They are having you match things on 52. Match each expression with its factored form. Okay, I'm going to let you do 52 and 53 on your own. First one, 52, you have to match them. The second one, they want to know which one is the factored form. Actually, 53 is a little interesting. Notice that you are taking a 6 out first. So if I take a 6 out, then I'm left with x squared minus 10x. What's 150 divided by 6, someone? 25? Is that what you said? Plus 25. They took a 6 out first. That's why all of the answers have a 6 out first. All you have to do is factor this to figure out what your answer would be.